Okay.
Yes, go ahead.
So yeah, so start with like patient history, like family history, and you will able to get to know like either the allele genotype, and then maybe that is associated with like AD development, and then there will be like pre-diagnose the blood test and the genotyping, and then the further we'll try to do the MMSE, which is one of the parameter that me and Helen and Liu Yuan we are actually interested maybe in the later, very later, maybe to use to as the one of the parameter we'll talk about later. And that's associated with a cognitive test. And another thing is once they actually can see from the primary care or like identify there's maybe a mild dementia impairment, and they will goes to like try to do MRI or try to do the FDG PET as earlier Professor John introduced. And furthermore, and if from those data, they will get to a next stage of diagnosis to amyloid PET or like CSF as our like the fluid test, and the CSF, the amyloid beta 42 and amyloid beta 40, which is showed in our information data sheet. Those have actually a number there for diagnosis purposes. So for earlier, I don't know those names, so that's why I think this is really informative for me and for everyone to interpret the data more. And the further, here is just generally a format of how actually what they give us the form is just a summary, a simple summary of what each question gives to us. And I think when I read about those forms, I personally like the version 10, which is a newer version, and what they currently use is following by AD score and based on like the immunohistochemistry like a test, and then following with different like different degenerative neural disease, and they classify them so in a clear way and compared to the form 9. And here I'm not going to go into too much detail because I think what more important information will be talking about those antibody tests, the scoring, or those CSF biomarkers in the later. Okay, so next. And here is one thing I wanted to include in the slide is when I do background research about the AD, and I think this is really interesting about the theoretical contributor to AD resiliences. And here is just like a schematic diagram, and here we can see there's a lot of environmental contributors and also biological contributors to this complex disease like AD. And one of them is like sex and hormone. And what we are actually currently really top topic here. And in addition is what cognitive reserve is the what at MMSE, the test might give us or educational attainment, like how IQ will affect AD development in the later onset of AD. And in addition, maybe also your like more biological contributor, like just the allele type, will more directly contribute to the AD development. So here, that's just a general schematic diagram. And which you give it to next. And here is what I saw like inside the, oh, sorry. Inside the our like Excel sheet, I specifically able to see SNAP 25, and also I able to see like this allele and the SNAP 25 able to appear in the form when they ask about the like allele according to the AD disease. So that's why included over here for genetic variance and the polymorphism. Then as we all familiar, the APOE allele and earlier Liu Yuan introduced for us that the 4-4 has to be the strongest risk factor for the sporadic AD. And the SNAP24 is actually another biomarker that is used for CSF to identify like is like higher. It actually is like an indicator of like degenerative snaps because it's dead neuron, and then the snaps protein fall off. It will be in the fluid, etc. Like the logic there. So this is a protein that is encoded gene, and such gene is located in the presynaptic neuron. Okay, cool. And here is the MMSE that I mentioned earlier, is the mini mental state examination. And the score is from 0 to 30. And the maximum score is 30. And the score is range from 20, when you have like 20 to 24, it just suggests a mild dementia. And when you decrease to 13 to 20, suggests a moderate dementia. And even less, it just indicate a really severe dementia. And then on average, the MMSE score of a person with Alzheimer's disease will decline about 2 to 4 points each year. So that's why when we go over the Excel sheet of extra information provided, you can see one patient will actually take tests each year and will have maybe the same score, maybe different score, maybe up and down. So there will be a trend, and we will most likely see like the patient get diagnosed with AD have a decline. So this is, this is just, and this is a kind of a diagram that what we usually would see. And another thing I really think is interesting that I previously don't know is about the pre-MCI, and the stage is actually started like around 20 years earlier than actually onset of AD, which is really important for the pre-diagnosis purpose of what we are doing. Yeah. And here is just, I just counted the unique CSF patient record that we have is like 439. And also you have some crossed over with some plasma. So that will be later, will be more detailed and correct later. And in addition, I'm just using the flow of what clinical diagnostic using right now. After you get like a MMSE test, and you kind of think, oh, maybe you have AD, maybe you're not, maybe we want to do an MRI, and this will be MRI typical like imaging, and the structural MRI in AD can be divided into like just measuring the size shrinking through the image of the brain. But one of the shortcomings of doing this is you cannot really differentiate the different degenerative neuron disease, or you cannot really differentiate like the underlying molecular pathway or actually mechanism if you do not do biomarkers. So that's why positron emission tomography PET involved here, and this one is specifically targeting amyloid. And this is one of the imaging here, and the amount of original distribution of amyloid beta in conjugation with other imaging and genetic marker can be used to categorize. And so it also can using to maybe differentiate from others using this. And one thing that I actually learned by doing this is really expensive. So that's another reason not all the patient able to maybe access to this. And this is, you can see like if you have Alzheimer's disease, maybe you have more amyloid beta aggregation, you will have like higher the red is more. And the control is like a blue and a more cold color. And next is the FDG PET. And this will be a little bit different compared to the earlier one, as earlier one is you want to see more, but however, this one is more like testing on the glucose metabolism. Is opposite. It's actually you see less metabolism on using the glucose. And in Alzheimer's disease, the other neurodegenerative disorder, glucose uptake is seriously diminished in region affected by the disease. So here is a image for us just to have an idea of why those are really useful for us to identify or diagnose for Alzheimer's. And this is just for my purposes when I go over the form, because I don't really know this term. I just include it for easy purposes. I'm not gonna go over it. And this is an important part of biomarkers. And earlier, Liu Yuan introduced us about how the underlying Alzheimer's, like pathological mechanism is about aggregation protein, either intracellular or intercellular. So this one, as I'm showing here, is an example of the intercellular. And this is the amyloid beta 42. So in general majority, it should be amyloid beta 40. So what they're measuring is the level of amyloid beta 40 versus amyloid beta 42 in the disease. So you will expecting more amyloid beta 42. That would actually give you the aggregation. And that will actually like show you, and this is actually one of the skill for you to using for phase 0 to 5. Detail is in the guide, and what they're usually using to either like scale them, or also like you can stain them in immunohistochemistry to able to see the aggregation in the brain sections, and also depending on which section they are doing the staining. But this is the main take home. I think is the amyloid beta 42. If it's a higher expression or more detect, it means like the patients might be the patients. Okay, so this is another like I think is most informative page for all this, because from the Excel sheet there's a lot of like numbers for all of those terms, and I just want to quickly go over with all of you guys. And the tau and the p-tau, they have a t-tau. T-tau is a total tau, and p-tau is a phosphorylated tau. And for here, it's like I think I kind of didn't really like remember now, but I think phosphorylated tau is increasing. But I will confirm later if I'm wrong. So feel free to.
This p-tau is most directly related to disease. Total tau is less direct.
Yeah. Okay. Yes. And SNAP 25 earlier we already introduced, as the notion is the SNAP loss occur early in Alzheimer's disease, and that synapse protein at active synapses could be a biomarker indicate the degree of synapse degenerations. And the NGTP75, which I go through the literature, trying to go through the literature through what is this, and the mainly like it says is a growth factor during the progression of Alzheimer's disease. Not much I can get out of it. Maybe need more research on this. And but it does help for identify or like diagnose for Alzheimer's. And NPTX2, which is in neuronal peroxide 2, and it's on the turn, is downregulated in brains of human subject with Alzheimer's disease. And another one, like WIM2, is promising SF marker of selective losses and memory performing Alzheimer's disease and healthy control. And all of this, I have reference and more detail in the notes. So I will upload this file and also update those more information, because this is not finished. And the NFL is abundantly expressed in large myelinated axon, and is promoted released into CSF and blood under axonal distress and degeneration. So you were expecting like more. That would be what we like predicting. So this is like the biomarker for like CSF. And this is like the scoring, what they provide for us. And I will not like go into much detail because we have the scoring numbers and we will probably interpret those numbers later and understanding or using them. That's it.